Hello, everyone. Today, I would like to give you a lesson on the topic coordinates, Part 1. Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that. In geometry, we have two-dimensional space and three-dimensional space. So, two-dimensional space has two coordinate axes. The abscissa axis, which we label as x, it's the axis that runs horizontally, and the ordinate axis, which we label as y, and it runs vertically. And in three-dimensional space, we'll have another axis, the applicate axis, and we'll label it as z. Please remember that in two-dimensional space, we have 4 quarters, and please remember the order of these quarters. That is, we move in the direction in which we set aside the angles. Well, how can we determine the coordinates of an arbitrary point? For example, let's take a green point that has coordinates 2 along the x-axis, 3 along the y-axis. How did we determine this? We simply count 2 cells from 0 along the x-axis and then move 3 cells up and get that the green point has coordinates 2 along the abscissa axis, 3 along the ordinate axis. Similarly, in the same way, we can determine the coordinates of the orange point, the blue point, and the purple point. Well, let's take three-dimensional space. Let's say we need to determine the coordinates of this point that I just highlighted. So let's assume that the coordinates of this point are 1 along the x-axis, 2 along the y-axis, 3 along the z-axis. So how did we determine this? We just need to move 1 cell along the abscissa axis, 2 cells along the y-axis, and 3 along the z-axis, and we will have this point in three-dimensional space. And how can we find the coordinates of the midpoint of a segment? To find the coordinates of the midpoint of a segment, you need to calculate the half-sum, arithmetic mean, of the corresponding coordinates of its ends. If the ends of the segment have coordinates a, x1, y1, z1, and b, x2, y2, z2, then the coordinates of the midpoint m, x0, y0, z0 are found by the formulas. x0 equals x1 plus x2 divided by 2, y0 equals y1 plus y2 divided by 2, and z0 equals z1 plus z2 divided by 2. To find the length of the segment AB, if A, x1, y1, z1, and B, x2, y2, z2, you need to use the following formula. AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. From the coordinates of the end of the segment, we usually subtract the coordinates of the beginning of this segment. The first problem before us is that we are given a segment with the corresponding coordinates, and we are asked to find the length of this segment using the given data. Well, we already have the formula for finding the length of the segment, so we must substitute unknown quantities into it. I subtract the coordinates of point A from the coordinates of point B, and we get that the length of the segment AB equals 17. In a similar way, we can find the length of the segment AB, also using the given data. We substitute the corresponding numbers into the formula and find that the length of the segment AB is 25. Problem 2. Here, we need to determine the coordinates of the midpoint of the segment AB using the given data. So, in the first picture, we are given points A and B with the corresponding coordinates. Well, knowing the formulas, we can substitute the coordinates of points A and B into them, and we will have that the coordinates of the middle of the segment AB are equal to negative 5.5. In the second picture, the same problem is shown, only we see that here we have added a z-axis. So we substitute the known coordinates of points A and B, and we will have that the coordinates of the middle of the segment AB are equal to 2,
-4, -3. Problem 3. The anti-drone complex is installed at point M, see figure. Determine the radius b of action of the complex if the firing point B is located at the boundary of its action. The radius r of action of this complex is the length of AB. So the length of the segment MB is the radius of this circle. So all we were asked to do was find the length of this segment BM. We remember the formula. We substitute the unknown quantities. I subtract the coordinates of point B from the coordinates of points A, and we have that the length of the segment BM is 29. Problem 4. The figure shows a regular triangular prism ABC, A1, B1, C1, point O, -6, 3, -1 is the intersection point of the diagonals of face A1, B, B1. Determine the coordinates of vertex B1 if A, 8, 10, -2. So first I will mark all the known and unknown coordinates, and we see that point O is the midpoint of the segment AB1. So, knowing the formulas for finding the midpoint of the segment, we can substitute instead of x0, -6, instead of x1, x, instead of x2, 8, and find from this equation x, and we will have that x equals -20. Thus, we can find y will be equal to -4, and z will be equal to 0. So the coordinates of point B1 are equal to -20, -4, 0. So if you understood everything today, I would give you an Azam yacht as a gift. If you are worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up, and I wish you to understand it as soon as possible. Bye!